enterprise attack surface is massive and continuing to grow and evolve rapidly. Depending on the size of your company, there are up to several hundred billion time-varying signals that need to be analyzed to accurately calculate risk. The result? Analyzing and improving cybersecurity posture is not a human-scale problem anymore. In response to this unprecedented challenge, artificial intelligence, or AI-based tools for cybersecurity have emerged to help information security teams reduce breach risk and improve their security posture efficiently and effectively. AI and machine learning have become critical technologies in information security, as they are able to quickly analyze millions of events and identify many different types of threats. From malware exposing zero-day vulnerabilities to identifying risky behavior that might lead to a phishing attack or download of malicious code. These technologies learn over time, drawing from the past to identify new types of attacks now. Histories of behavior build profiles on users, assets, and networks, allowing AI to detect and respond to deviations from established norms. Unfortunately, AI is a very popular, often misused buzzword at the moment. Not unlike big data, the cloud, and every other next big thing, an increasing number of companies are looking for ways to jump on the AI bandwagon. But many of today's AI offerings don't exactly meet the AI test. While they use technologies that analyze data and let results drive certain outcomes, that's not AI. Pure AI is about reproducing cognitive abilities to automate tasks. Here's the crucial difference. AI systems are iterative and dynamic. They get smarter with the more data they analyze, they learn from experience, and they become increasingly capable and autonomous as they go. Data analytics, on the other hand, is a static process that examines large data sets in order to draw conclusions about the information they contain with the aid of specialized systems and software. AI refers to technologies that can understand, learn, and act based on acquired and derived information. Today, AI works in three ways. Widely available today, improves what people and organizations are already doing. Emerging today, enables people and organizations to do things they couldn't do otherwise. Being developed for the future features machines that act on their own. An example of this will be self-driving vehicles, when they come into widespread use. AI can be said to possess some degree of human intelligence, a store of domain-specific knowledge, mechanisms to acquire new knowledge, and mechanisms to put that knowledge to use. Machine learning, expert systems, neural networks, and deep learning are all examples or subsets of AI technology today. Machine learning uses statistical techniques to give computer systems the ability to learn using data rather than being explicitly programmed. Machine learning works best when aimed at a specific task rather than a wide-ranging mission. Expert systems are programs designed to solve problems within specialized domains. By mimicking the thinking of human experts, they solve problems and make decisions using rules-based reasoning through carefully curated bodies of knowledge. Neural networks use biologically inspired programming, which enables a computer to learn from observational data. In a neural network, each node assigns a weight to its input, representing how correct or incorrect it is relative to the operation being performed. The final output is then determined by the sum of such weights. Deep learning is a part of a broader family of machine learning methods based on learning data representations as opposed to task-specific algorithms. Today, image recognition via deep learning is often better than humans, with a variety of applications such as autonomous vehicles and scan analysis. AI is ideally suited to solve some of the most difficult problems, and cybersecurity certainly falls into that category. With today's ever-evolving cyber attacks and proliferation of devices, machine learning and AI can be used to keep up with the bad guys, automating threat detection and respond more efficiently than traditional software-driven approaches. At the same time, cybersecurity presents some unique challenges, such as a vast attack surface, tens or hundreds of thousands of devices per organization, hundreds of attack vectors, big shortfalls in the number of skilled security professionals, masses of data that have been moved beyond a human-scale problem. A self-learning, AI-based cybersecurity posture management system should be able to solve many of these challenges. Technologies exist to properly train a self-learning system to continuously and independently gather data from across your enterprise information systems. That data is then analyzed and used to perform correlation of patterns across millions to billions of signals relevant to the enterprise attack surface. The result is new levels of intelligence available to human teams across diverse categories of cybersecurity, including gaining a complete, accurate inventory of all devices, users, and application with any access to information systems. Hackers follow trends just like everyone else, so what's fashionable with hackers changes regularly. AI-based cybersecurity systems can provide up-to-date knowledge of global and industry-specific threats to help make critical decisions based not only on what could be used to attack your enterprise, but based on what is likely to be used to attack your enterprise. It is important to understand the impact of various security tools and security processes that you have employed to maintain a strong security posture. AI can help understand where your InfoSec program has strengths and where it has gaps. Accounting for IT asset inventory, threat exposure, and control effectiveness, AI-based systems can predict how and where you are most likely to be breached, so that you can plan for resource and tool allocation towards areas of weakness. Insights derived from AI analysis can help you configure and enhance controls and processes to most effectively improve your organization's cyber resilience. AI-powered systems can provide improved context for prioritization and response to security alerts, for fast response to incidents, and to surface root causes in order to mitigate vulnerabilities and avoid future issues. Gmail has used machine learning techniques to filter emails since its launch 18 years ago. Today, there are applications of machine learning in almost all of its services, especially through deep learning, which allows algorithms to do more independent adjustments and self-regulation as they train and evolve. The team at IBM has increasingly leaned on its Watson cognitive learning platform for knowledge consolidation tasks and threat detection based on machine learning. The networking community uses breakthrough ideas to address the unsustainability economics of present-day networks. Juniper sees the answer to this problem taking shape as a production-ready, economically feasible self-driving network. In recent years, AI has emerged as a required technology for augmenting the efforts of human information security teams. Since humans can no longer scale to adequately protect the dynamic enterprise attack surface, AI provides much-needed analysis and threat identification that can be acted upon by cybersecurity professionals to reduce breach risk and improve security posture. In security, AI can identify and prioritize risk, instantly spot any malware on a network, guide incident response, and detect intrusions before they start. AI allowed cybersecurity teams to form powerful human-machine partnerships that push the boundaries of our knowledge, enrich our lives, and drive cybersecurity in a way that seems greater than the sum of all its parts. Thanks for watching this video. We hope you enjoyed it. If you want to learn more, check out our website at www.chelseacybersecurity.com.